welcome to section 1.3 notes. We're going to be on this several days, so we're going to call this section 1.3 part A. Notice we're hitting a lot of Florida state standards in this section, a good piece of them. So we're going to begin with the ruler postulate. Now the ruler postulate states that every point on a line can be paired with a real number. This makes a one-to-one correspondence between the points on the line and the real numbers. So here I've drawn a segment actually, and I've labeled 3 points, and then I've put a ruler up to that. And notice that point A, we're going to assume that this segment, we'll say it starts there. And notice that this point A is linked with 1. So the coordinate of A is 1. And C is corresponds to 2, so the coordinate of, oh, I've got this wrong, let me switch these. So the coordinate of C is 2, and then the coordinate of B is 4. So all the ruler postulate says is that we can align points on a geometric line to a number line, and once we can do this, now we can find the length from B to C, or from C to A. So that's huge. The distance between points A and B is the absolute value of the difference in their coordinates. Do you all remember what absolute value is? Now, we've got several vocabulary words here. Here's another one, difference. When you see the word difference, that is a very, very sophisticated way of saying subtract. And absolute value of a number, the absolute value of -3, is asking how far away from 0 is -3, and we don't care what side of 0 it's on. It is 3 units from 0. Absolute value of 3, how far away from 0 is 3? It is 3 units. We don't care if it starts on the left. We don't care if it starts on the right. And the reason why they put this absolute value, suppose we want the length from, suppose we want AB. What that means is there's nothing on top. I need the distance from A to B. So there's 2 ways I can do this. I can say it's the absolute value of 1 minus 4, or I can say it's the absolute value of 4 minus 1. Now, when you do this subtraction, this yields -3. This yields +3. Why do we need the absolute value bars? Because we don't care what side of 0 it was on. The distance is always going to be positive, so we're going to get 3. So that is our ruler postulate. So if I want to find the distance because there's nothing on top, from E to I, that is going to be, here is E, here is I, so the coordinate is going to be the absolute value of 4 minus 1. Remember I said if you add, subtract, multiply, or divide, I must see the work. So that's going to be 3. The distance from H, where's H? Let me get a different color. H is here, A is over here. So I'm going to say that's the absolute value of 9 minus a -3. Now when we subtract a negative, it's the same thing as adding a positive. So that's going to be that's going to be the absolute value of 12, or 12. So now I want CT, here is C, here is T, so that's going to be the absolute value of 5 minus a -9, which is going to be plus +9, or the absolute value of 14, or 14. Now I'm going to do from I over to M, so that is going to be 4 minus a -7, or 4 plus 7, which is 11. So now you get to try, I want the length or the distance from TA. Remember that you need to highlight and show me your work. So while you pause that, I'm going to continue. Now we want to find a point from one endpoint of the segment such that it and the length of a segment are in particular ratio. In other words, locate a point on line segment EI that is 2/3 the length of segment, let's see, I want to locate a point on line segment EI that is 2/3 the length of EI beginning at point E. So how are we going to do this? The first thing we're going to do is find the length of EI. Well, we know how to do that. The length of EI, so notice I don't use a little bar on top, is equal to absolute value of 4 minus 1, or 3. All right, so now I'm going to add that length onto the coordinate of point E. That is the point that is 2/3 the length. Okay, 2/3 the length of AB from point E. I don't know where this came from. All right, so what am I going to do? At this point, I'm going to ignore this, and what I'm going to do is I'm going to take my length, and I'm going to multiply it by 2/3, my ratio, you could say. So this would be 3 times 2/3, and that's going to be 6/3, which is 2. In other words, from E, I'm going to add this length of 2, so I'm going to make this 3. I'm going to add the length, that length refers back to my 2, onto the coordinate of point E. So if I'm at E, and I move 2 units, that's going to be 1, 2. What is the coordinate? What did they ask? Locate the point on line segment EI that is 2/3 the length of EI beginning at point E. So the point that is 2/3 the length of EI from point E is going to be what? That is going to be 3, because I started at 1. Let's do it with arithmetic. E is 1. So I take 1, I go 2 more units, I will be at 3. So that is how I find that. I find the length, multiply by the ratio, and then if they had said from point I, then I would have started here, I would have gone back 2 units, and I would have been at 2. All right, let's do another one. All right, find the point that is 1/4 of AT from point A. So 1/4 of AT. Here is A, here is T. So I'm going to say the length of AT is absolute value of AT, 5 minus a -3, which is going to be 8. So now I'm going to take 8, and I'm going to multiply by 1/4. That's going to be 8/4, which is 2. So now, from point A, where's point A? Point A, I'm moving 2 units. So find the point, the coordinate of the point that is 1/4 from A of segment AT. Coordinate is -1. All right, so find the point that is 1/4 of AT from point T. All right, so now instead of from A, I have to go what is 1/4 from T. So I still can use what's up here. I still find the length from A to T, which I have. I take my 8 and I multiply by 1/4, which is 2. But now, here what I did is I said -3 plus 2 equals -1. Now I start at T. T is 5. 5, and I'm going to be going this way. Oh, that should be from T, and that is going to be 3. So we got to kind of know where we're going. So I'm going 5, I'm going to move 2/3 in the opposite direction, 2/3 towards A, and I'll be at 3. So it's important to know that how A and T are situated on the number line. Here's another one, MH. So here is M, here is H. So the first thing I do is find the length from M to H, and the length from M to H is the absolute value of 9 minus -7, which is going to be 16. Now I need 3/8 of 16, and that is going to be 8 divided 16, 2 times 6 units. So the question is, do I start at M and move 6, or do I start at H and move 6? Well, what does it say? From point M. So I'm moving 6. 1, 2, 3, 4, 5, 6. So I would say -7 plus 6. The coordinate is -1. So now I want the point that is 7/8 of MH from point H. So I need the distance from M to H. The distance from M to H is going to be 9 minus -7, which is 16. So now I'm going to take 7/8 of 16. which is going to be 14, and I'm starting at h. H is on the right, so my h is 9, so I'm going to say 9 minus 14 because I'm moving to the left, so I'm subtracting will be negative 5. Watch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There's my coordinate, negative 5. All right, so now it is your turn to find the point that's 7/10 from CE. So you need to pause me, you need to highlight this, and I need to see the work. All right, segment addition postulate says if you use 3 points, A, B, and C are collinear, and B is between A and C, then the distance from A to B plus the distance from B to C must be the distance from A to C. So here's my segment I'm talking about, A, B, C. So when we talk about AB, let me do that in a different color. When we talk about AB, we're talking about the segment or the length from A to B, which basically is this distance right here. And then what we want to do is we want to add to that the distance from B to C. Well, the distance from B to C would be this part of the number line, and if I go to here, that would be this. And does it make sense that if you take this segment and add it to this segment, that the result will be this whole entire segment AC, which is going to be the distance from A all the way to C. Segment addition is one of those postulates that is, again, kind of common sense. I think if I hadn't even mentioned those names or anything, that you would have been able to help me. Now, I kind of jumped straight into algebra. So let me not go straight into algebra. So let me give us a segment. So if I told you this is A, and this is D, and this is E, and I told you that AD is 8, and DE is 4, and I want the length from A to E, then you would tell me, well, we take the distance from A to D, which is 8. We take the distance from D to E, which is 4. Now notice, I never draw my scale diagrams to scale. Then the distance from A to E is 12. Now, I could have said, well, suppose the distance from A to E is 16, and the distance from A to D is 5. Well, now they're telling us the whole thing is 16. This part is 5. How are we going to find out what that part is? Well, what do you add to 5 to get 16? Another way to say that is 16 subtract 5 is 11. In other words, if this were 11, 11 plus 5 is indeed 16. Now, that's good, and you need to be able to work with it at that level, but this is much more fun. Whenever I can connect geometry to algebra, I will. So here we have it. They're telling us the distance from A all the way over to Y is 38 units. They've told us that the distance from A to M happens to be the expression 8x minus 19. The distance from M to Y is the expression 5x plus 5. So you are going to use segment addition postulate, segment addition, to write an equation in order to find x. And what it says is it says take the first part, which is 8x minus 19, add to that the second part, and what should it give you? It should give you the whole. And if I ask you why, remember justify, 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 you will tell me because of segment addition. Now when we simplify first. Notice that I've got 8x and 5x on the same side, that's 13x. I've got negative 19, positive 5 on the same side, which gives me negative 14. So now to solve, remember we just connect our addition first. So I'm going to have 13x is equal to 12, 3, 4, 52. And what did I just do? I did the addition property of equality. And now we're going to divide by 13, and I'm going to get x is equal to 4. And what did I just do? I did the division property of equality. And what told me, how did I know to write this equation? It's all about segment addition. Let's try another one. So they're telling us now that DO, draw a diagram on your paper when you're doing this for homework. DO is 2x minus 1, because it's great to write it on the diagram. OG is x plus 5. And now they're telling us the distance from D all the way over to G is 7x minus 24. So what kind of equation are we going to be able to write for this? And let me fix that. Okay, it's not working. Let's see if I can. There we go. All right, so here we go. So segment addition tells us that I can say 2x minus 1 plus x plus 5 equals 7x minus 24. I expect you to be able to justify this equation. That is going to be segment addition. So now 2x plus x is 3x. 5 minus 1 is 4. That's going to equal 7x minus 24. All right, from here I am going to subtract 3x. Now I'm not going to ask you to justify anymore on this part, but this setting up I will. So 4 is equal to 4x minus 24. All right, from here I am going to add 24 to both sides. So I'll end up with 4x equals 28. And then our last step is to disconnect this as division. And we're going to get x is equal to 7. Now, did they ask you for x? What did they ask you for? They asked you for the length of DG. Well, what is DG? DG is right here. DG is 7x minus 24. In other words, if you want the length of DG, then it's going to be 7 times 7 minus 24, which is 49 minus 24, which is 25. We do one more, and then it's a U try, and we're done for the notes for today. Your U try has this segment. All right, here we go. CA is 23. All right, CA is 23. AT is 8x plus 9. And now they're telling us that AT, the distance, CT, the distance from C to T, here all the way over, is 11x minus 4. So we're going to say part plus part is equal to the whole, which is 11x minus 4. What justifies this step? Segment addition. So we're going to have 8x, 23 and 9 are on the same side, so I've got 8x plus, that looks to me like 32, is equal to 11x minus 4. Now it's equation solving that we did at the beginning. So I'm going to subtract 8x. I do that to keep my x's positive. So I'm going to have 32 is equal to 3x minus 4. Now I'm going to add 4, and I'm going to come up here. So I'll end up with 36 is equal to 3x. Now I'm going to divide by 3, and I'm going to get x is equal to 12, which is great. But they didn't want x. They wanted AT. Okay, well, what is AT? AT, if you look at the problem, is 8x plus 9. So to find the length of AT, it's going to be 8 times 12 plus 9, which is going to be 96 plus 9, which is going to be, I believe that's 105. Forgive me if I'm wrong, I'm not using a calculator. So now here is your diagram, and here is the information I have given you. Again, we always do the highlighting on the U try. I expect to see work. And this completes, this is 1-3A.